All right, number 15. Oh no, we're sorry. We're on 14. We're on 14 C. Yeah, so we're going to do this as kind of a reminder of what we did yesterday. We want to write cotangent squared of arc cosine of x squared as a algebraic expression. Now this one has a cotangent squared on it. So the first thing that I'm going to do is I'm going to write it as the entire cotangent squared. That's what it means. Okay? And then my next layer is the cotangent layer. And then I have another layer, which is arc cosine. And then believe it or not, I have another layer. I have another layer that's x squared. So we have purple, blue, red, and black. There's a lot of different layers to this problem. A lot of different layers. Okay. Now, when you have an expression like this, where do you start? On the inside out or the outside in if you do an order of operations? Inside out. Okay. So on the inside, we have x squared. That's the innermost layer. Does x squared represent an angle or a ratio? It's a ratio because it follows our cosine. Now, I'm going to put it over 1 to make it look more like a ratio. Now I'm going to go off to the side and I'm going to draw a generic reference triangle with some angle theta because when I take the arc cosine of x squared, it gives me some angle theta. And I'm going to label the two sides x squared and 1 based upon the cosine ratio. Cosine is x over r, yes, yes? So the x, which is different than the x squared, is your horizontal, that's x squared, and the hypotenuse is 1. Now I'm going to use the Pythagorean theorem to find the missing third side. Now notice this. This is important for decomposing in the next step. When you have your hypotenuse, which we do, right? Notice what the Pythagorean theorem does. I get x squared, quantity squared, plus y squared equals 1 squared. I want to solve for y squared, so I get y squared equals 1 minus x to the fourth. And when I take the square root, I get plus or minus, which I'm going to take the positive because I don't know what x is. I get 1 minus x to the fourth. Now notice this. This is important. When you have a number minus something, that means that this number here, the one in front of the minus sign, that's your hypotenuse squared, always. You're not going to have subtraction unless you have your hypotenuse, because the Pythagorean theorem is a plus sign formula, right? A squared plus b squared equals c squared. So the only time you get a minus sign in your Pythagorean theorem is when you solve for one of the short sides, and in that case, the number in front of the minus sign is your hypotenuse squared. Very important. But for now, I'm just going to label the other side as 1 minus x to the fourth. Now that I have all three sides in terms of x, or a constant, I have any one of the 6 trig ratios that I care to pull off of this triangle. All right, so now we're on the blue layer. Which ratio am I actually pulling off? I'm pulling off the cosine. I'm sorry, we got the arc cosine. I'm pulling off the what? I'm on the blue layer. I'm pulling off the cotangent layer. Cotangent is x over y, yes, yes? So that's going to be x squared over the square root of 1 minus x to the fourth. And that's where we stopped yesterday. But that is still all inside of something squared. And so now we just do the next algebraic step. I'll square both the numerator and the denominator, which gives me x to the fourth. All over the radical goes away now, 1 minus x to the fourth.
So you just, whenever you're not finished with the operation, you just leave the square root of something at the bottom? Because I thought normally you can't have a square root in the middle.
No, square roots in the bottom are fine unless we're talking about the unit circle, like a number.
Okay.
Yeah, that's a good question. Yeah, we leave the square root in the bottom here. We don't need to rationalize the denominator. We only did that on the unit circle because we wanted 2's in the bottom all the way across. We didn't want 2's in some places and square root of 2's in others. So we rationalized the bottom to make them all the same. And there's your answer. There's your answer. And if it were just a radical in the bottom, we would be fine. Okay? So here's the step again going forward. Make a ratio out of the ratio by putting it over 1. Draw a triangle. Label the two sides based upon the given ratio. In this case, it was cosine. Find the third side by the Pythagorean theorem. And a reminder, whenever you have a minus sign under the radical, the number in front is your hypotenuse squared. Then pull off the ratio that's in the front based upon x, y, and r. And if there's anything else to do, like the squared, then you just do that at the end. Okay. Now let's try going backwards. We want to decompose this now, which is an algebraic expression, we want to decompose it into an inverse trig or trig of an inverse trig. Okay? We want to decompose it into a trig of an inverse trig of a ratio. That's our goal. I wanted to get it to something that looks like that. All right, so here's all you need to do to start. The radical itself will give you all of the information that you need to draw your picture. Now, I'm still going to draw a picture. So there's two ways to draw the picture. Picture number one, picture number two. Picture number one is going to be the following. Whenever both of your terms underneath the radical, let me just rewrite it right here, 1 plus x squared. Whenever both your terms on the radical are positive, when they're both positive, these are going to be your two legs squared. The legs are the short sides. Yes, yes? Those are your two legs. So what's the square root of 1? 1. What's the square root of x squared? X. Now, I don't know which leg is which, do I? I don't know if the vertical leg is 1 or the horizontal leg is x or vice versa. So guess what the other way to draw this is? Instead of 1 on the vertical and x on the horizontal, I can put 1 on the horizontal and x on the vertical. They're both okay. I just know that I have the two legs. Okay? Now, guess what the third side is going to be? No, if I use the Pythagorean theorem, if I know one of them is 1 and one of them is x, it's 1 squared plus x squared, and I take the square root. The radical itself is your other side. The radical is the missing third side. In this case, it's the hypotenuse. So the radical is where you always look for to start. You look under there in the radicand. If they're both positive terms, then the square root of each of those are going to be your short sides, and there's two ways to do it. The third side, if you want to use the Pythagorean theorem again, that's fine. Or you can just realize the third or missing side, whatever's left, is your radical. Okay, now, here's what I want to do. I need to set up something that creates the ratio. I need to create the simplest ratio, which is going to be ax to the n over b. Okay, that's my simplest ratio. I want it to be a power of x over a number. So for us, in this example, the simplest ratio is x over 1, which is just x. The simplest ratio is just x over 1, which is just x. There's 5 other ratios, right? 1 over x, x over the square root of 1 plus x squared, the square root of 1 plus x squared over x. We can list all 6 trig ratios, but what's the most user-friendly of them all? X over 1, x over 1. Okay, so now it's going to be specific to this diagram. How do I create the ratio x over 1? What ratio is that? It's horizontal to vertical, which is what? Cotangent. So I'm going to put an x here instead of x over 1, and in front of it, I'm going to put an inverse cotangent. You don't put cotangent, you put an inverse cotangent because you want that to be the ratio. Okay, and then you look at the original problem. Now you say, okay, I want to create the radical over x. I want to create the radical over the x. Which ratio is that if it's radical over x? Well, that's r over x, which is what? R over x is not cosecant, it's what? It's secant, and I put secant out front. And there's your answer. Secant of inverse cotangent of x. Now, you could verify that that works by doing what we just did on the previous example by going forward. Put x over 1, draw a triangle, label your two sides, and then find the hypotenuse and pull up the secant ratio, and you'll see that you get that. Now, there's another version of it over here. Okay, if I want to pull off the x ratio here, it's still x over 1, but what ratio is that on this setup? X over 1 is y over x, which is what? Tangent. So I'm going to put inverse or arctangent in front, and that creates that ratio. And then I look for what I'm trying to create in the end, which is the radical over the x. And the radical over the x would be r over y. What's r over y? Cosecant. And there you go. There's the second one. So there's two right answers here. There's two decompositions. Now, what do you notice about the two answers? Are they related to each other? You said opposites. You said inverses.
There's like co-opposites.
Co-op. I like that better. They're co's of each other. These are co-functions of each other. Co-functions of each other. Co-opposites is a good way to say it. All you got to do if you have one of them to get the second one is either add a co to the name if there is no co currently there, or take the co away if there's already a co there. So instead of secant on the outside, the next one's going to be what? Cosecant. And on the inside, we have cotangent inverse. So if you take the co away, it becomes what? Tangent inverse. So there you go. If you have one, you have the other. You either add a co or you take a co away to both of them. You either add a co or you take a co away to both of them. Got it? All right. Let's look at the second one now. I want to decompose this one. I start with the radical. I start with the radical 1 minus 9x squared. Do you see the minus sign there? Okay, when you have a minus sign, this means this is your hypotenuse squared, and this is a side squared. You don't know which side it is. But whenever you have a minus sign, the number in front of the minus sign is your hypotenuse squared. So let's draw the picture. I'm only going to do it one time this time, and we'll see if we can come up with the second one. So what am I going to label my hypotenuse? What's the square root of 1? 1. And what am I going to label one of the other sides? What's the square root of 9x squared? 3x. Now, do you want to put the 3x on the vertical or the 3x on the horizontal? Does it matter? No. I'm probably going to put the 3x on the horizontal just because it has an x in it, and I feel better with 3x on the horizontal. Now, what's the missing third side? Well, it's the radical itself. And you could verify that by the Pythagorean theorem.
So the missing, wherever the missing third side has is the radical.
Correct. The missing third side is always the radical.
So when you're subtracting something inside of the square root, that's when it's the
hypotenuse is in front. Hypotenuse squared is in front. Yeah. And then you got one of the, so instead of having the two short sides, the two legs, you have the hypotenuse squared and the leg squared. When they're both added on the inside, you got both legs squared. That's what you have to remember. Okay?
How does it become 9 and still have the square?
What?
Would it not
How does it have the 9 and still? I'm sure what your question is. What's the square root of 9x squared? That's the square root of 9 times the square root of x squared, which is 3x squared. Or 3x. Watch. If this were 1 and this were 3x and this were just y, you would say y squared plus 3x quantity squared equals 1 squared. And you get y squared plus 9x squared. That's how it turns to 9. And then you get y squared equals 1 minus 9x squared. And then you take the square root and you get this. Okay, so the other side is always the radical. You can verify by the Pythagorean theorem, but you don't always have to do that. Okay? We're trying to memorize patterns here. All right, so now I need to create the simplest ratio. The simplest ratio is going to be 3x over 1. That's your simplest, most user-friendly ratio. So I'm going to put down 3x over 1 or just 3x right there. Now I need to say in front of there, what ratio generates that from my triangle? It's the horizontal over the hypotenuse, which is cosine. So I'm going to put an inverse cosine in front. An inverse cosine in front. All right. Now I'll put that in parentheses, and now I return to this right here, and now I say, what ratio do I need to pull off to get the 3x over the radical? Well, 3x over the radical is my horizontal over my vertical, which is like my x over y. What's x over y? Cotangent. And there's your answer. It's cotangent of inverse cosine of 3x. That's one of the two. Or what would be the second one if we had drawn it with our short leg on the vertical? Of what? Inverse sine, yeah. Of 3x. There you go. Cotangent, so you take away the co and you get tangent. Cosine, so you take away the co and you get inverse sine. Perfect. Those are the only two that I would accept. Okay. Now, granted, there are other ways to generate the ratio besides 3x over 1, but I'm not interested in those complicated. I don't want any of the other 5 ratios generating this triangle. I want the simplest looking version, which is your power of x over your constant. All right. So far, so good. We got 2 under our belt. Let's switch it up just a tiny bit here. What if I got a 1/3 out front? Multiplying by a third is the same as dividing by what? 3. So let's just rewrite that so it looks like a quotient. We'll put it over 3. Okay. So now I look for my radical. Let's just look at the radical off to the side. I have a minus sign, don't I? So whenever I have a minus sign, the number in front of the minus sign must be your hypotenuse squared. It's got to be. And then the other one is going to be one of your legs squared. So when I draw my little triangle here with theta, what am I putting as the hypotenuse? I'm putting 3. It's the square root of 9. And what's my other leg if I take the square root of 16x squared? 4x. Where do you want to put it? You want to put it on the bottom or on the vertical this time? You go ahead and put yours on the vertical. I'm going to put mine on the horizontal again. I'm just going to stick with what worked last time. But you can put it on the vertical. And then what's the missing third side? The radical. Yeah, you can just say the radical, the whole thing. Now I have all 3 sides. Okay, so now it's time to generate the ratio. The simplest ratio is going to be 4x over 3. 4x over 3 is the simplest ratio. No, because I don't want the x on the bottom. 3 over 4x is the next simplest ratio, but it puts the x on the bottom, which is really 3/4 x to the negative first. So we want to keep the x on the top. Good question. That's not a bad looking ratio, but it's not the best. It works though. It'll work, but it's not the one I want. I want the power of x over the number. All right, now, which ratio will generate that? Which is the highlighted ratio here? 4x is horizontal, 3 is the hypotenuse, so that's x over r, which is which ratio? Cosine. So I'm going to go ahead and put arc cosine here instead of inverse cosine. That works too, doesn't it? And then I go to my ratio here. I want to get the radical over the 3. Radical over 3 is what? Y over r, which is sine. So I'm going to put sine in front. So you get sine of inverse cosine of 4x thirds or sine of arc cosine of 4x thirds. And of course, once you have that one, if you did put the 4x on the vertical, Ryan, did you do that? I think you were going to do that. Oh, okay. I thought we were going to do it differently and compare answers. But it's fine. You don't have to. What would the second answer be? Instead of sine in front, it would be what? Cosine. And instead of arc cosine in the inside, it would be arc what? Sine. You take away the co, and then this stays the same. 4x thirds.
On the quiz, would you prefer us the arc cosine?
I don't care. I don't care if you use inverse cosine or arc cosine.
Well, we have a test.
Well, we have a test on Wednesday. Yeah, and this is your free response question. I'll have you decompose it both ways. Okay? There you go. Any comments or any questions? Scooby Dooby Doo. I think we're 15 minutes in if anyone needs to use the restroom. Just make sure you take the candy cane and make sure you have your hall pass or your ID on.
Well,
Yeah.
25 minutes in, so better watch out.
You better not cry.
Better hurry up. You only have like 3 seconds to go to the bathroom.
Oh yeah, what's 950 minus 15? 35? So you have 19 minutes to make it.
Oh, I thought we get out at 9:40. Oh, we do.
Oh, 9:40, you're right. So it's 25. So you have 10 minutes. Okay.